A long straight wire of radius A carries a steady current I. Radius is A, that is R is equal to A, and I, that is current, is equal to 1. The current is uniformly distributed over its cross section. The ratio of the magnetic field B and B dash at radial distance A by 2 and 2A respectively from the axis of the wire is we need to find here. Okay. Then the ratio of the magnetic field B and B dash we need to find here. So here the radius of the wire, it is given as R, that is A, and the current in the wire I is equal to 1. Then the radius at an inside point R is that is A by 2, and outside we denoted by the symbol R dash is equal to 2A. This is also given. Then for the inside point, the magnetic field B is written as, that is B is equal to mu naught into I into R divided by 2 pi R. If I substitute the values, mu naught into I into R is equal to A by 2 divided by 2 pi R is A square. Then we get the value, that is B inside BI is equal to mu naught I, and A will get cancelled. 4 will come to the 2 will come to the denominator. This becomes 4 pi, and here A square and this A will get cancelled. This A remains as it is. Then BI is equal to mu naught into I divided by 4 pi A. For the outside point, the magnetic field, that is B dash, is equal to same mu naught into I divided by 2 pi R. Then we can substitute the values here. It becomes mu naught into I divided by 2 pi into R value 2 times A. This becomes mu naught I divided by 4 pi A. Okay. Then the ratio is means since here B and B dash, both the value, it is a mu naught I divided by 4 pi A and mu naught divided by 4 pi A. I can write it as, then the ratio of this one, B divided by B dash is equal to 1. Option C is the right answer.